All right, everyone. We've talked about correlations and the fact that it's an association between two dependent variables. What we're going to do now is go through how to run correlations in SAS-Jump. And I have my Excel document pulled up here, and as you can see, I have height, foot length, and arm length in this data set. And I'm actually going to run two correlations. I'm going to run one correlation where we have to accept our null hypothesis, where the correlation, there is no association between the two dependent variables. And the second one I'm going to run is going to show an association, just because I want to give you an idea of what these look like. All right, so the first thing we're going to do is open SAS-Jump and open our data table, which for me is histocorrelations. Open, and I'm going to import that. And the first comparison, the first association we're going to look at is height and foot length, okay? And as you can see here, I have height in centimeters, foot length in centimeters, and arm length in centimeters. So what can you tell about this data? Look at it. Well, it's continuous, right? All of these data are continuous because to run a correlation, we have to have two continuous dependent variables. So that's what I have here. Let's check in our little window to make sure all of our data columns are listed as continuous. Uh-oh, we have foot length and arm length as continuous, but as you can see here with height, for some reason, Jump has listed height as a nominal data form, which we know it's not, it's continuous. And I've told you many times, just click on this little bar and you can change the data type, but for some reason, Jump is not letting us do that. So my advisor, Jim McGraw, always says that statistical programs and computers in general are just high-speed idiots. So we have to know what we're doing when we're importing our data, when we are using our data. So since we can't change it over here, what we're going to have to do is go to the column header, double-click on that, go to data type, and our data type is not a character, it's numeric. And our modeling type is continuous. So this is changing this data type to a continuous form. And I did this on purpose. Whenever I filled in, let me just push OK, so now we have a continuous data set. Whenever I filled in the data on this Excel sheet, I did that as a text instead of a number because I wanted to show you that sometimes you may have to click on this header to change your data types. Okay? All right, so the first thing we're going to look at is the association between height and foot length. To do that, we don't use fit y by x. We don't use fit model like we've been doing with ANOVAs and with regressions. Instead, for a correlation, we're going to go down to multivariate methods and then over to multivariate. All right. Since we have all of our data are dependent variables, are y variables. So we're going to select both height and foot length and put them in our y variable window. So we're casting them into a row. All right, then we'll just push OK. And as you can see here, this is a fairly confusing looking output. What we want to do though is we want to go up here to this red arrow beside multivariate, and we want to choose Pairwise Correlations, right here, Pairwise Correlations. All right, now we get something at the bottom, and this is what's going to be important for me. So just like with a regression, we don't first look at the R value, the correlation coefficient. First, we need to look at our p-value to see if R is even significantly different from 0. So we go down here under Pairwise Correlations, and we go to the far right, and we see this significant probability, and this is our p-value. And we see, oh my goodness, p-value is 0.8085. Is that less than 0.05? Definitely not, right? So because of that, we have to accept our null hypothesis. We have to say that there's no association between height and foot length. All right, so let me open up sketchbook and get my pen out here. So how would we state that in a results statement? Well, just first off, what we know, p-value is greater than 0.05, so we have to accept our null. So we would state that in a results statement as height in centimeters and foot length in centimeters are not correlated. All right, and then we would put in our, well, let me move this here so it makes more sense. We put in our sentence R equals, and we get that R value right here. This is our R value where it says correlation. So R equals 0.04, 0.04. P equals, what did our P value equal? Right here, 0.81, we'll round up. So 0.81. And that would be our results statement for this grouping that showed no association. And actually, if you look at this figure, you can see that we basically have a shotgun splatter that looks like our null hypothesis. So we're not seeing a directional association, either positive or negative. But now let's look at one that has a correlation, a positive or a negative correlation, because I just wanted you to see the difference in this output. So what we're going to do now is look at foot length and arm length, okay? Or I'm sorry, height and arm length. So again, we'll go to Analyze, Multivariate Methods, and Multivariate. This time I'm going to select height as my first dependent variable and arm length as my second dependent variable. So the question we're asking is height and foot size correlated? Are they codependent? Well, I've not looked at my p-value yet, but this looks more promising. We have something that looks like a positive association. But let's look at the actual p-value. So we go to this red arrow by Multivariate, look at Pairwise Correlations, and then we go down to the bottom here. And what we see, we first again look at our p-value, which is less than 0.0001. Is that less than 0.05? Yeah, it is. So we're seeing that we have a correlation between these two dependent variables. So now that we know we have a correlation, let's look at our R, our correlation coefficient. And we see that our R value is 0.7240. It's a positive correlation, as you can see here. So how would we state that in our results? Well, first off, just to reiterate, we see that we have a p-value less than 0.05. So whenever we're writing our results statement, we would say height in centimeters and arm length in centimeters are positively correlated. Then we would put our R value, which was 0.7240, and our P value, which was less than 0.0001. Okay, that's how we would state that. Just to point out, we could also have a negative correlation, which would look something like this. Okay, so that's different than what we see in our results we just ran. How would we know that it's a negative correlation? Well, we can tell because there's a negative association. It's going down. The data points are going downward. But if we have a negative association, our R will also be negative. Okay, so not too hard, not too bad. That's how we do a correlation in SAS Jump, and the next video is going to show you how to graph these results in Excel, and this is actually one of the simplest graphing techniques you can do. So stay tuned.